Hello everyone, I'm Autoregressive from Virginia Tech. Today, I'll present our work on Infinity-RoPE, a unified, training-free inference framework that enables action-controllable infinite video generation from autoregressive self-rollout. As you can see in the teaser, our method enables three capabilities simultaneously. Infinite length video generation that maintains quality over minutes, real-time action control, where the model instantly responds to new prompts, and dynamic multicast cinematic storytelling with scene transitions that preserve character identity. All of this is achieved without any fine-tuning, purely through inference time modifications to positional encoding and cache management. Current autoregressive video generation models face three fundamental limitations. First, the finite temporal horizon. 3D-RoPE assigns absolute temporal positions to each frame, capping generation at the training horizon, typically 1024 latent frames. Beyond that, quality collapses. Second, prompt responsiveness degrades. As the KV cache grows during long rollouts, earlier context overwhelms new action prompts, and the model stops responding to instructions. Third, there is no way to create the cinematic scene transitions within a continuous generation. The core mechanism is block relativistic RoPE. Instead of absolute temporal positions that grow without bound, each new generation block reuses the same local RoPE coordinates relative to the model's training horizon. We reset positional information for each block. Earlier blocks in the KV cache are rotated backward, so every block in the attention window sees the positional pattern within original training distribution. This figure shows two variants. In A, with a fixed cache size, we maintain a sliding window. The cache horizon stays bounded. In B, with unbounded cache, earlier frames naturally compress to semanticization tokens as they age. This is entirely training free. We only change how positions are assigned at inference time, and the model handles it because every local window looks like it is training data. How do we achieve real-time action control during infinite length generation? The top row shows 4 cache strategies. Without KV cache, there is no temporal coherence. With full KV cache, earlier tokens dominate and new prompts are almost ignored. KV cache builds the cache, but it is super slow. Our KV flush keeps just 2 anchors. When a new action prompt arrives, we flush all cache tokens, except the global sync token, which stabilizes attention and prevents degenerate softmax, and a last generated frame, which preserves temporal continuity. The bottom shows results. Single subjects, she stands, jumps, and sings on the ground. And finally, she sings out loud. The third capability is multicast cinematic generation via RoPE cut. The diagram shows how it works. At each cut point, we shift the temporal RoPE coordinates by a jump parameter delta. The top row shows the prompt level coordinate blocks. The middle row shows how these map into KV cache with the jump. The bottom row shows the full coordinate timeline with the fixed cache horizon. The model perceives a fresh scene at each cut, new location, new setting, but identity information persists through the cache. The bottom shows example results. A Harry Potter inspired sequence and a Titanic-inspired sequence, each with multiple syncs preserving character identity throughout. Here we compare our method against 7 baselines for long video generation. Our quantitative results confirm the qualitative findings. The plots on the left show 4 metrics across different generation lengths: 30 seconds, 60 seconds, and 2 minutes. Our method consistently outperforms baselines. To summarize, we presented Infinity-RoPE, a unified, training-free inference framework. Thank you for listening. Please visit our project page at Infinity-RoPE GitHub.io for interactive demos, code, and additional results.